talks. And first up, we have the implementation of a rights-aware IIIF server at New York Public Library, presented by Alessandra Vertrees.
All right. Hello, my name is Alessandra Vertrees. I'm a software engineer for NYPL's DAM team. And my team manages digital collections, which is a living database of new materials that are added every day, featuring prints, photographs, maps, manuscripts, audiovisual materials, and more. We have two image servers that we use within DC, our legacy image server, which is images.nypl.org, and then a rights-aware IIIF server, which is the topic of this presentation. We started looking into IIIF because images.nypl.org not only needs derivatives to be pre-cut, but it serves files if we have them. So there are no protections in place to stop rights restricted images from being accessed via a direct image URL to the server. Therefore, we're unable to stop anyone from directly linking to restricted images, even if it's been pulled from DC. The way we control access to our assets is isolated within the logic of the web app itself. And this causes problems such as BuzzFeed embedding our restricted images in an article and citing us as a source. Some things to consider for our rights-aware implementation. On the technical side, there are no users in DC. So there's no auth or user roles for us to use to grant access to materials. And the logic within DC looks at three things. So it's the right status of the capture, the derivative type or the dimensions of the image being requested, and the IP address of the user. What we did is essentially copy the logic from DC and put it into an API endpoint. And then this endpoint looks at it takes in an image ID and a list of IP addresses and compares the IP addresses in the request body to a list of IP addresses that we have for our branch locations and research libraries, and then returns the rights status or the rights profile for the image, and then two new fields. Is restricted for IP, which is a Boolean that we use mostly for testing. And then the star of the show is the list of available derivatives for that image ID and the IP addresses in the request body. We use this in our Cantaloupe server. There's a delegates file that has an authorized method that's called for all requests to the server, and it has a hash that gives us the image ID, the resulting size of the image, and the client IP of the request. And we determine what derivative is being requested by mapping the resulting size from the context hash to our existing derivative system. And then we get the rights profile from the endpoint, which we have to pass in the image ID and the IP address from the request. And then we determine if the derivative is allowed to be returned by the server by comparing the derivative that was being requested to the list of available derivatives returned by the endpoint. What is next? We use IIIF in a small set of collections on DC right now. They're our most popular collections on the site. We refer to them as our pilot collections. And that's it for the implementation. We have, what do we gain from this and what's next? We get all the cool IIIF perks, such as eliminating the need for complicated image processing and interoperability. But one of the benefits that we get by making it harder for people to download or view restricted images via a direct URL, not only do we eliminate legal risks, but we can also use or display images in other applications without moving rights logic. So this has been really beneficial in the project that I'm leading right now, which is the rewrite of digital collections using our React component library. And due to the difference in aspect ratios of thumbnails in our component library to the existing site, it's become a requirement for the project to globally implement IIIF. And then what have we learned? So in the pilot collections and the rewrite of DC, we've noticed a couple things about our approach that I feel like are important to share. For one, we don't have a lot of JPEG 2000s or pyramid tips. So our image server has to do a little bit more work to cut derivatives. And then every request to our image server is making an API call and our API response times aren't as efficient as we would like them to be. So our IIIF calls are a little slow. But these are the like key takeaways. So we were able to do this pretty fast, which was important for our team because our team manages a lot. And we were small at the time of implementing this. So we didn't have to rewrite our pipeline. We get to work on cool new projects, and by putting pressure under our feet, by putting pressure on our existing services and infrastructure, we are putting fire under our feet to make our products better for our patrons. Our Cantaloupe repo is public, and these are the two links to the two versions of DC that I mentioned in this presentation. And if you have any questions, feel free to reach out to me, Chris Kelly, who could not be here this week, or Lana Vitsa, who's in the audience.
Excellent, thank you. Okay, up next, we have analytical support tools for historical drawing maps, utilization and development of IIIF Georeference extension and Mirador plugin. And that is presented by Satoru Nakamura.
Thank you. Hello, my name is Satoru Nakamura. I'm from University of Tokyo, Japan. So today I'd like to talk about the tools to support analysis of historical drawing map, especially using IIIF Georeference extension and Mirador plugins. So my university has some historical drawing maps. This example shows the map from 15th century. The actual map is about 7 meters wide, so it's kind of one of the large maps. So, sorry. So thanks to IIIF image API, so we publish high resolution image. And also we add 700 annotations on the map, so you can search based on the place names as well. And maps like this have been created several times in Japan. So oldest one is the left one from my university, but others are from National Archives of Japan. So there is a need to compare these images for analysis. So in this presentation, I want to talk about two tools. One of them is the tool compliant with IIIF Georeference extension, and another is Mirador plugin to compare images. And this tool is the interface is similar with all maps, but some additional functions are provided. So the movie doesn't work. So okay, so okay, it's a different image, but the left side is modern map, and the right side historical image maps. So each has annotation based on IIIF Georeference extension. So you can navigate the places based on annotation. And also, sorry, this is Japanese, but there is the function to search annotations. So based on those functions, you can get to the location you want to search. I think I don't need to talk about Georeference extension, but this tool based on Georeference extension, and also I created data with all maps editor, which is very great tool, I think. So this tool also open on my GitHub, so if you are interested in it, please check it. And another one is the Mirador plugin to compare images. I'll try again the movie. Okay, so we have similar images, and each has each annotation. But if they have the same annotation, you can navigate to the same locations. So right side has only one canvas, but this one has 3 canvases. So this, if you select the annotation which occur in each set, the both images, you can get to the location of those places. So you can use this tool with such as map image and also a picture image. So this is my university old map. So if you can compare the old map and also some old pictures based on annotations. So I particularly extended the annotation description based on the Tropiify presentation API. Specifically, we add the CID, common ID, to assign a common ID to corresponding places, place names. So I think it might be better to use not just literal, but like PIDs, such as URI, but currently just we add some common ID for the images. Also, we developed the plugin for the Mirador tree. This function allows us to rotate image at any angle. So drawing historical map has a variety of shapes and orientations. So I think it's better to it's better to allow us to rotate the images at any angle. Okay, so this is the last slide for future plan. For the tool compliant with Tropiify Georeference extensions, I want to develop some features such as alignment using points other than markers, such as DIN or some other technologies. And also for the Mirador tree plugin, I heard that Mirador tree will be upgraded to the Mirador 4, so I want to update this plugin to be compatible with version 4. And lastly, I and my colleague developing the Cultural Japan, which is kind of aggregation service for IIIF Manifest related to Japanese cultural resources. So I want to add some function to collaborate with these developed tools for the Cultural Japan. Okay, thank you so much for your time.
Okay. Great, thank you. Up next, we have Tropiify, a Tropy plugin for exporting IIIF collections, presented by Martim Passos.
That won't work? No? No. Okay. Hi all. Thanks for having me. My name is Martim. My notes are gone, so God help. I'll be presenting Tropiify, which is a plugin for Tropy. We'll get to that soon. But first, I would like to start with a few questions. Are you a solo researcher struggling to publish your research online? Is the technical barrier crashing down on you? Or maybe you just worry about your project's longevity once funding says bye-bye. Well, try Tropiify today. So what is Tropiify? Tropiify is a plugin that allows you to export Tropy projects as a level 0, also known as static IIIF collection. It leverages Tropy's UI and functionalities to turn it into a manifest and collection editor. So let's be honest, IIIF is all fun and games If you're working with a big one, it's Getty, Northwestern, British Library. But what about the people working with small local archives? Or maybe major institutions outside of the area where IIIF was widespread? Should they be left out and not able to use tools such as Canopy or Exhibit? No, they shouldn't. So Tropiify is a tool that you can use to bridge that gap. So first things first, what is Tropy? So for those of you who are not familiar with it, Tropy is an open source, lightweight, cross-platform application that allows you to manage and describe your research images. It is translated into 11 languages, supports multiple metadata schemes. It's thoroughly documented, which is very important too. Who is it for? Tropiify is aimed at non-technical researchers, especially those working with materials not yet available as IIIF manifests. Small institutions could also use it since they have limited IT resources to expand access to their collections. So picture here is Tropiify acting as an intermediary between Tropy and Canopy or Exhibit, to name a few. Let's take a minute to admire its neat interface and see what Tropy can do. So it has all the basics you would expect from an application these days, so you can drag and drop stuff into it. You can merge items into a single object. You can reorder them. Those will be your canvases later on. You can define multiple metadata schemas and templates to describe your objects, items, documents. You can tag and organize your items into categories. And last but not least, it has a fully fledged annotation interface. So it has support for rich tags. You can manipulate images, select regions, all the cool stuff that we all love to do. It also has some core plugins, such as the IIIF plugin that allows you to import 2.1 manifests. The CSV is also very useful as you can import items via spreadsheet. So Tropiify, how do you use it? You can use the default metadata template, which they call Tropy generic, and it will work out of the box. It has all the basics you need, like title, date, description, rights. Or you can work with a custom template following I believe, simple naming convention to add more metadata, to add map plays, for instance, if you're interested in that. And you can have more control over your manifests. In the plugin settings, you can set some general settings, such as the collection label, the ID, some label for properties such as homepage and required statement, and you can also pick a different template to export your items. Upon export, it will tile your images and create manifests with all your annotations and metadata. The output, as I said, is a single folder that can be hosted for free, for example, using GitHub pages. And Tropiify is proudly developed by Arca. And these are some features in our roadmap. We would like to add update support, support the tags that you use in Tropy. So Tropy also has support for PDF, which currently is unsupported on export. Integration, so I know I said it's like free solution, but if you have some budget, you could also integrate with serverless IIIF, more on that coming up. And integration with the import plugin too. So let's take the 2 minutes I have left and hopefully watch this video where I create a collection from scratch. So drag and drop. We can group items that refer to the same document. Let's batch edit some properties, add creator. Let's add the date. Let's create an annotation just for kicks. There you have it. The canvas is here. This is a single object. Let's give it a title. You can see ingredient and list view. That's at rights, very important. It will fail export if some item does not have an ID, so be sure to fill all your IDs. You get a picture now. Let's jump to the last one. We can configure the plugin, the settings, the name, the label, the ID that you'll be hosting them in. On-page label, required statement. You can also add some boilerplate text to your required statement, so like provided by or whatever you want. Export, you just pick a location, it will, this is real time. And it will export the items, title them. Now let's real quick test it, serve it up real quick. We can inspect the output. Here you go. You can see there's the collection. Let's see if if the annotation made it through. There it is. Final task, Mirador. Let's see it in action. Here you go. All your items, your manifests. Let's see the annotation there. There you go. You can also pass the deep zoom, the rights are there, everything in place. And that's pretty much it. Thank you for your attention. Feel free to put me an email. And I'm happy to hear if you have any new things. So thank you.
Thank you. Up next, we have Watch Me spin up a production-ready, lightning-fast IIIF image service in less time than it takes to deliver this talk. Okay, Karen, Shaw, let's see it.
Pressure. Hi, I'm Karen Shaw. I'm a software developer with Northwestern University Libraries, and I'm going to run through a production-ready install of the serverless IIIF image service in less time than it takes to do this lightning talk. So at a really high level, for anyone who's not familiar, what is serverless IIIF? It started as an experiment from our developer, Michael Klein, who wanted to see if a Lambda function-based solution would be a cost-effective approach to solve Northwestern's scaling needs. And what we found was that it served image requests in milliseconds, scaled almost infinitely, and incurred minimal costs. The serverless model with no running server and an event-based operation allows Lambda to scale up automatically as requests increase. This ensures compute resources are used only as needed, reducing both financial and environmental costs. Thank you. Thank you. Sorry about that. So this is serverless IIIF, and this is pre-recorded of the whole installation. So this is the code repository for serverless IIIF. It's not part of the Sambera community. I am going to go ahead and go to the documentation site for the project, click on the docs, and I do want to point out there are a couple really basic prerequisites. It does run in the AWS cloud, so you will need to have an AWS account with sufficient permissions, and you also will need an S3 bucket to hold your source images. So I went ahead and created the source bucket called Lightning Talk. I uploaded a couple images from our digital repository. They're layered pyramidal TIFFs, but they can be either pyramidal TIFFs or JP2s. And name them 1 and 2. I do want to point out there are 3 different installation paths on the docs, and I'm following the least technical one, which is deploying via the AWS serverless application repository. So go into the repository in the AWS console, click available applications. Do make sure you have the box checked to show apps that create custom IAM roles, or you might not find it. I'm searching for IIIF, and there's only a couple things that come up, and that middle one is the one you want. Click on it. I'm going to give it a name, and the source bucket for my images, click acknowledge. The rest can stay defaults for now and deploy. And since AWS serverless applications deploys cloud formation stacks, you can go into the cloud formation console and monitor the progress. And click refresh. There it is at the top. The app we just created, create in progress. So what is it actually creating? If you look under resources, there's 5 resources that are going to get created. It's basically just one function written in Node.js. And then the other 4 things are just things the function needs, like dependencies, IAM roles, and permissions. So click refresh, and it's done installing. So if you click on the output tab, you can see 2 things. It's exposing 2 endpoints, one for the IIIF API version 2 and the other for version 3. So clicking on version 2, I'm getting okay, so that's a good sign that it's responding. So I'm gonna go ahead and give it the name of one of the images I uploaded, and there is the info.json response for that image. And if I want to switch to the version 3 API, I can just change 2, 3 in the URL. And also I can obviously put in IIIF parameters and get the image response. So just one more thing to show that it's up and running. I have a really simple web page here that just has the Clover IIIF image component. So I'm going to grab the info.json URL for one of my source images and give it to Clover, the Clover component, and then just drop the page in a browser. And there is Clover, zoomable IIIF image. So woohoo, it's done installing. And since there were a couple more minutes, I wanted to do one more thing. There's this great IIIF server load test tool developed by Glenn Rosen. You basically just give it a text file containing IIIF URLs, and it runs a load test for you. So we did that. And the recording within the recording. And so you're presented with a page to configure the max users. We're setting at 300 users max at one time, spawn 20 new users per second. We're going to run the test for 1 minute, and that's the function URL, the IIIF URL above, and click start. So once it starts going, you can see in the bottom blue line is spiking up the number of users pretty quickly. Top green is number of requests is going up into the hundreds pretty quickly. The red line right below that is errors, which looks really close to 0. The purple line is saying 95% of the responses are coming in under about 400 milliseconds, and the yellow line is average response times around between 100 and 200 milliseconds. So that's looking really like it's scaling pretty well. I'm not letting this run to the full minute in the interest of time, but if you do any quick statistics up there, you get this report of the statistics for the run, and you can see that in the minute we served over 112,000 requests, errors, fails 0, and the average request, there's 0 errors. An average request is just like 128 milliseconds. So I feel like a serverless IIIF passed this load test with really flying colors. And that's the end of it. So thank you for listening, and I hope you check out the project and found this helpful.
Okay, so Maia Mackay is going to present turning textiles into sound to make archive collections more accessible.
Hello, good afternoon. My name's Maia Mackay, and today I will be telling you about turning pattern fabrics into sounds to make archival collections more accessible. I am speaking today on behalf of myself and my project partner, Harith Ibrahim. We are interns with the Digital Creativity and Cultures Hub at the University of Leeds. We are part of the Digital Library Infrastructure Project, and we are new members to IIIF. We use IIIF to support us in digitizing our archival collections. The archival materials we chose to focus on comes from textiles from our special collections. We selected 19th century project books from the Yorkshire College, and the project books explore the process of weaving. So these are some photos of cymatic patterns. Cymatics occurs due to resonance and displacement of particles in response to a frequency. I noticed the similarities between the cymatic patterns and those in the project books. I thought about the way in which sound can make a pattern, and I wondered if this could be reversed to turn pattern into a sound. I felt that this could be an inclusive way for people with visual impairments to engage with the archive. This is where our project in translating the patterns into a different medium in order to create an accurate way of experiencing the archival material began. So the project books contain different details about type of weave, thread width, and yarn arrangement for the corresponding fabrics. The yarn arrangement is important as it changes the pattern of the fabric. The specific yarn arrangements form the basis of our project. In order to gain a better understanding of the structure of the fabrics, we have used software to create 3D models of the fabrics. The next stage of our project is to use the 3D models we have created of the fabrics to make multi-physics models in order to extract the exact wavelengths and frequencies of the fabrics. There are supposed to be a few videos here, but it's fine. But what was supposed to be here was we have used AI software to predict what the fabrics might sound like. Okay. That's fine. If you're really interested in hearing them, you can email me and I can email them to you. So as the yarn arrangements are a big part of our project, we work on levels as tiny as individual threads, which is why the deep zoom features of IIIF are critical in digitally conveying the textures of our fabrics, which is really important to us. The clarity of the audio resources is also very, very important in the experience we aim to provide. It is important to us to maintain the original properties of the fabrics, so that they can be translated rather than producing something which is interpretive or descriptive, to ensure we create an accurate and exact representation of the fabric existing in a different medium. IIIF's resources support us in upholding the authenticity of this experience. The features combined support the relationship between the two sensory portrayals of the fabrics. We have really loved learning about different ways of presenting archives and art. We believe that IIIF is a great platform to showcase our work as it can be accessed worldwide. IIIF opens the door to more collaborative research in this field, and we are also very excited about the further developments in IIIF's 3D support and its future potential is very exciting. Thank you very much for listening.
Okay, before we dip into the program as it's published, who's ready to hear some textiles make sense? Very excited. Okay.
Hopefully it works.
Oh, we wouldn't put you up to it again.
There are two more.
Oh. I'm glad we took a few minutes for that because one, it did sound like that. That's exactly what they looked like. Up next, we're going to welcome Chip Goines to present handling HTJ2K images with VIPS and Kakadu.
Hello, my name is Chip Goines, software engineer for the Harvard University IIT department. And I'm here on behalf of our repository architect, Stefano Casu, and I'm going to be talking about how to use high performance J2K images with VIPS and Kakadu. Now, high performance J2K is an encoding that came out, I think, about relatively recently, and it replaces part one of the JPEG 2000 spec. And what's nice about it is that it's actually optimized for modern computer architecture. So you really actually get much more significant performance than the original encoder. And as you can see here in this graph, it really, you get, I think about half, actually twice as fast losses encoding. And although loss is the same, but for delivery, it's really impactful because they don't have the graph for it. But when this is a graph from Stefano's paper of Code for Lib last year. But what he did was they tested a IP image server with Kakadu and HTJ2K, and they saw that decoding performance was increased by twice as fast for lossy and 20% faster for lossless. So for any IIIF image endpoint that's serious about speed, it's really something that we wanted to look into. You would want to look into. But there is a problem. Now, as I work with Kakadu, unfortunately, Kakadu is basically the gold standard, or really the only game in town for high performance delivery of JP2s in our space. And so it has some a little bit inflexible. So you can only write C++, and Java bindings. So anything like Python or Ruby, it's not, they're kind of on a lock. And anything you want to do with, say, any other development things, you usually have to, it has to do things that don't scale well. So it doesn't have to shell out or fork a process, and that just does not work in a production environment. And there's no one-to-one mapping between the original old school JP3000 and HTJ2K. So enter VIPS. VIPS, it's been around for several years now. And it's an image library that probably many of you use. And it has bindings for Python and a lot of scripting languages, and it's very extensible. So what Stefano did recently is that we collaborated with them and we created a new plugin. And it lets us do a basically command line interface where we can translate existing JP2000 files to HTJ2Ks. Right now, it's available for all of the original bindings, but right now we've only tested it in Python. Although it's open source, you still need a Kakadu license. So that is one small barrier to entry, fortunately. One thing we want to do going forward is that the library has about 60 million digitized, 60 million GP2 images, roughly. And what we're happy about this is that it gives us a uniform performance across the entire environment. A lot of our images were scanned 20 years ago, and they don't render correctly. So we're hoping that we can use VIPS into our ETL pipeline to create a whole new set of HTJTK files to create great experiences for our patrons. And I want to thank Stefano, who could not be here, Mike Smith, Anthony Mew, Zach Colford at Kakadu. And thank you for listening for my scratchy voice.
Can't wait to tell you all what we have coming up next, because it's a video. So we have a dual presentation coming up. So this is a joint presentation from Chris Gilman at UCLA, and we were supposed to have Alicia Haltro here from Yang to present this together, but she had a very last minute conflict, and we have a recording. But we knew this was coming. We're ready, right? Okay.
I'm ready.
Okay, Chris says he's ready.
You pause it for just a second.
Hi, I'm Kim, and this is Alicia.
We were too ready.
Just want to say, I'm Chris Gilman. I'm Digital Curriculum Program Coordinator here at the UCLA Library. As Caitlin said, we're jointly presenting, I with Alicia and Kim, and we proposed a kind of bundle with Digerati to also talk about the digital Florentine Codex from a technical perspective. So we'll start with the video, and then I will jump in live, continue the presentation, then we'll have the next presentation, and hopefully we'll all be coherent. Okay, now.
Virtually, he presents to you the digital Florentine Codex, Códice Florentino Digital, which just launched in October and is the result of a major collaborative initiative. The story of the Florentine Codex takes place in Satoru, the sister city of Tenochtitlan, the capital of the Mexica people and of the Aztec Empire prior to invasion of the Spaniards. Both cities are buried today below Mexico, but circa 1500 they were located on an island in Lake Texcoco. Now picture this, it is 1576. A Spanish Franciscan friar and a group of novice scholars and artists sit in the scriptorium of the first European institution of higher learning in the Americas. Outside the college, indigenous people were dying of one of the worst epidemics in recorded history, the Great Pestilence of 1576. The team worked tirelessly to complete the magnum opus known today as Florentine Codex. The Florentine Codex is the most important manuscript treated in 16th century New Spain because of its encyclopedic content about pre-Spanish and early colonial Mexico. It was created between 1575 and 77, so compiling the information took 3 decades. It's the product of a large-scale collaboration between the Spanish Franciscan friar Bernardino and a team of indigenous Navajo collaborators, many of whom were trained by Salvin at the convent. Their names are listed here. However, in their research, our team identified a total of 9 scribal hands and around 20 artist hands, so many more Navajo collaborators were involved. The Codex was sent to the King of Spain shortly after completion, but ended up in the hands of the Medici by 1587. It has remained in Florence as a Biblioteca Medicea Laurentiana ever since. The Florentine Codex has 12 illuminated books amounting to almost 2,500 pages, bound into 3 volumes. It's a bilingual illuminated manuscript with 2 columns of text, Spanish on the left and Nahuatl on the right. Zagun's Spanish translation paraphrases the Nahuatl, so although complementary, the 2 texts are often distinct. Modeled on Roman and medieval encyclopedias, the Codex addresses topics ranging from medicine to astronomy, in addition to Book 12, which is a Catalan account of the Spanish invasion. Because the images provide such critical information, in addition to the 2 alphabetic texts, our colleague Códice has proposed that the images should be considered a 3rd narrative. The digital Florentine Codex unlocks this encyclopedic content by making the text and images searchable. You might ask, why does this content need to be unlocked? Aren't there scans available online already? The answer is in this photo. It illustrates the challenges of working with the manuscript. You have to consult numerous publications seen here on my desk to access the whole codex, unless, of course, you're comfortable reading early modern Spanish and now in 16th century handwriting. The digital Florentine Codex brings these transcriptions and translations and the digitized codex together, combining canonical routinely referenced text with translations and created specifically for the DFC. All is freely accessible online. And now turning it over to Alicia.
We also included summaries of Book 12, written in a modern variant of Nahuatl and voice recordings, both made by Eduardo de la Cruz, director of IIIF. With around 1.5 million speakers, Nahuatl is considered an endangered language. One of IIIF's main missions is language revitalization, an effort to which the DFC contributes. To make the codex's images searchable and to draw out the content of the 3rd narrative, our team conducted extensive iconographic and stylistic research and has each image in the DFC with multilingual keywords. As we've heard, the Florentine Codex is a massive compendium of information, nearly 2,500 handwritten pages with just as many images. To make the digital Florentine Codex, the digitized folios of the Codex were combined with an impressive quantity of data that was created the old-fashioned way by humans, by hand. The DFC aggregated audio files, plain text, multilingual vocabulary, and a staggering number of keywords or tags assigned to the images of the Codex so that they could be searchable. Now let's give you a walkthrough of the site. The entire interface is bilingual in English and Spanish. From the home page, you can search via a keyword or scroll down and explore the Codex based on curated browsing categories, books of the Codex, deities, occupations, everyday Nahuatl, individuals, and animals. Let's explore the category everyday Nahuatl and the topic textiles. Hovering over the image, you can search text or images. Let's select images. And these are the results of all images tagged with the word textiles. You can narrow the search, filtering by book, to see only the images tagged with textiles in book 9, The Merchant. From here, we can select a specific image, one of the feather workers, And here the image is enlarged and basic information is provided. Scrolling down, the image keywords, we've exposed the multilingual tags that describe this image. Clicking on any of these keywords will generate a new search, such as Latino or artist here. And here we see all the images that our team identified as the hand of artist here. Now, let's perform a keyword search. For example, Martim, the name of the young Nala woman who translated for Códice. This time, click in the text. And let's click on Book 12, Folio 26R. This screen, the three narrative view, is a part of the DSP because you can access the three narratives together, the two texts along with the images. And because Book 12 presents a unique historical narrative of the conquest of Mexico from the perspective of the Aztecs, we included additional content, such as audio recording of the Navajo text. And let's take a listen. Finally, you can enjoy the Codex in a simpler interface by clicking on this book icon up here. And by closing the window, we return to the three narrative view, and that is the gist. Back over to you, Tim.
Because the DSP is such a valuable educational resource, we have been working on getting it into school and university classrooms through workshops and by creating freely accessible learning guides. Up next, Chris will tell you more about teaching materials he's developing in collaboration with local professors.
Center view. See if I can. Okay, so now we'll switch to in-person presentation and the matter of how the digital Florentine Codex has been and will be used for teaching and learning in college level and K-12 curriculum. As the GRI team is wrapping up the sort of final bits of the Flow project itself, our work is just beginning. I will outline and illustrate what I believe to be Flowcode's extraordinary potential as an instructional resource and highlight features enabled by IIIF. Oops, wrong way. First, however, I should say that the instructional program is not actually starting from scratch. In fact, the Florentine Codex project has been actively engaged in innovative teaching for many years, long before the launch. I was fortunate enough to have been witness and party to this when Kim Richter visited Occidental College, where I used to work, and helped facilitate student use of the Florentine Codex imagery and expertise, and of course taught by Alicia, who is one of its principal scholars. Students completed an experimental collaborative project in Scalar that included authentic imagery, visual analysis, and storytelling, as well as sound recordings of students reading selected passages in Spanish and Nahuatl. One moment in class struck many of us in our institute as particularly telling about the promise of the content and the approach to project support via critical information literacy, and we published an account of it in DH+Lit. I will quote, in a course on Spanish Nahuatl Florentine Codex taught by history professor Alicia, there was a remarkable discussion about metadata, of all things, and students used the entire duration of the lab period to interrogate whose voices and interests should be represented in the names and other information typed into metadata fields, requiring them to think through and make decisions about how to categorize knowledge and content when those are contested spaces due to colonial oppression of indigenous cultures. Fast forward to the launch of Flowco in the fall of 2023. As it turned out, one of the students in that class, Roxanne Valley, featured in the presentations for her work on with the GRI team on the project as a master's student and now a PhD student at UCLA. To my complete surprise, she mentioned her discussion about metadata and digital project work as an undergraduate at Occidental as pivotal in her choice of a life path. LAS, Adolfo Guzman Lopez, a local public radio media personality, took note as well. And wrote, as a first generation student, the Codex exposed me to entirely new ways of learning, research, and even careers, said recent UCLA master's graduate student Roxanne Valley. She took part in the unveiling to talk about her research into how handwriting in the Codex reveals how many Laquilos worked on it, like Maria Velasco. Valley learned about the Codex as an undergraduate several years ago. Until learning about the Codex, Valley was planning an academic career studying some aspect of Latinas in sports. What we really want to underscore here is that there is a reason for doing all of this work. The IIIF digital collections and digital editions of the magnitude of the digital Florentine Codex literally do change students' lives. Understanding its value and potential, to LA regional faculty accepted my offer to integrate the digital Florentine Codex in their courses for the spring terms, that is just now, at Chapman University and UCLA. Amy Buono is a professor of art history and was already planning to teach a case study course on the history of Tenochtitlan, and Chenling Liu, who you just heard from, who specializes in the history of science and medicine, developed a comparative study of 3 national cultural historic encyclopedias from China, France, and post-conquest Mexico. I worked closely with both of them to design their courses and to apply a special course template. I developed a scaffold engagement with digital collections. I'll give a brief overview and show a few example activities for illustration as follows. So you heard from Ben and Chenling about the kind of 3 unit sequence. This is a course template. It's sort of well represented by its interactive homepage. It is developed in the learning management system Canvas, which has a modular structure, and there are 4 basic modules, one for conventional course weekly readings, discussions, and lectures sequenced by topics. The other 3 so-called unit modules bundle digital learning activities that can be completed in class or at home as assigned. They scaffold engagement with primary source sets, such as the Florentine Codex or digital collection. Unit 1 attends to curatorial matters. Unit 2 focuses on developing proficiencies, such as annotation, and Unit 3 supports public authorship and digital projects, such as scaling. Let's see if you can see this. So this is just to give you a sense for how the sausage is made inside of these modules. I'll show you 2 typical long scrolling lab activities, which are built on the frame of a discussion forum and modified by means of a special template. The instruction proceeds from the top down. So you can see this is 1 scrolling page in Canvas. So as a kind of anatomy of the lab activity with pointers indicating respective sections for concept, activity, tools, steps, etc. In this case, lab activity is designed to get students over the hump of any anxiety intended related to things that look like code, such as HTML, a IIIF Manifest, or other long and complicated strings of characters. In addition, it introduces students to fundamental tasks of close viewing through a fun slider puzzle activity. In action, the students essentially stare down, then copy a block of HTML code for a table, paste it into a discussion forum reply, toggle their rich text editor, then solve the puzzle by sliding or cutting and pasting individual detail sections to a single IIIF image from the Florentine Codex. When solved, they post and reflect upon their results. Here's another lab activity used for foundational instruction about IIIF. It's focused on standardized IIIF image URL and its capacity for manipulation to deliver whole or partial images of various sizes and qualities. It includes a simple embedded viewer developed by Ben Johnson, but Princeton develops
a IIIF image URL in real time. A suggested URL displayed above presents a simple I, for example, when loaded into the blank. Various manipulations of sections of the URL yield different results, including a default medium-sized presentation of that I's complete image in color, where you can see the little I in the context of that page. So it's right there on the right-hand side. Lab activities in units 1 and 2 scaffold discrete proficiencies and concepts that students then apply meaningfully in complex final projects, such as these respective scalar books from Chapman and UCLA, so in the same courses. Because many lab activities and project support were shared between these courses, they resemble each other. These are individual student multimedia essays aggregated in a team-based collaborative project, much like an edited anthology. Scalar is well suited to complement what Floco has to offer, and in actual experience, students excitedly navigated the digital site's many offerings, including browse, tag, search, and other features, and they imported media using the high-quality IIIF content manifest and GRI metadata. They applied their skills at visual annotation and tested their observation and interpretations with a collaborative audience of their own peers in the class as an online media authoring platform with capacity for long-form text. Scalar helps teach 21st century literacies and scholarly communication, especially at the intersection of image and text. So where do we go now? The Floco team at GRI, along with a number of interested collaborators in the scholarly and educational communities, are excited to tap into the potential of Floco in combination with other IIIF-based digital items and collections. The GRI will convene and support a network of scholar educators, will curate a IIIF teaching collection with Floco and other digital resource collections. I will be working this summer with Kevin Graciano and Lisa Souza to develop activities for their upcoming courses this academic year. And we plan to publicly share related curriculum in learning management systems for undergraduate and K-12 courses. All this work has been accomplished by an exceptional team of colleagues, which includes local and international scholars, Getty staff, and various collaborators and institutional partners. Please keep checking the Florentine Codex site as they continue adding features and resources. And if you're interested in discussing educational uses of IIIF, please visit our Birds of a Feather or Fish of the School session on Thursday. Thank you.
Okay, and up next, we have building the digital Florentine Codex from user research to production by Maia Mackay.
Should we put that in there?
Yes. I may have to change my glasses. I can use this. So we've heard from Alicia and Kim, about the kind of reason behind the Florentine Codex, its purpose, why it's important, the motivation for the project, and something about the scholarly effort that went into creating the content. So I'm going to talk a little bit about the kind of how of the project, how it was developed, how the digital Florentine Codex as a digital resource was built, and the relationship between that and IIIF as a kind of standard and format. So we started with a set of user needs that come from user research that had been done by the Getty. So they had an understanding of some user personas, who the desired and intended users of the Florentine Codex would be, whether that was academics, indigenous people, scholars of all kinds, high school students, and so on. And they had a set of kind of needs and requirements that had emerged from that. We're working within this kind of classic design thinking double diamond paradigm where we're kind of gathering insights, spotting opportunities in those insights, and then coming up with some concepts to explore. So in that process, we ideated with the Getty, came up with some concepts for what we might build,
And then finally went into a kind of implementation phase where we built the digital Florentine Codex as a kind of finished product. We started by clustering the requirements that had emerged from the user research into 6 broad categories. So there was search, finding content by text, by tag, by features within the images and so on. Navigation, both hierarchically by exploring the kind of book through its volumes and books and chapters, but also exploring it through other themes. We needed to allow the user to read the text, view the images, and listen to the audio of the NAWAT audio, carry out different kinds of analysis, such as comparing texts, comparing different translations and transliterations, and then reusing that content. And we've already heard from Chris about how some of that content has been reused in educational contexts, and also very clear kind of credit information, copyright information, citation information, to make sure all of the scholars who were involved in creating the content were credited. From this set of kind of features, we carried out an extensive prioritization exercise, kind of clustering these together in this kind of bullseye diagram to work out what were the key features of the Codex that we had to then build as part of the digital Florentine Codex as a digital product. We had to come up with a content model. There were a lot of different use cases, and we had to understand how we could store and represent the content in a way that would serve the needs of those users. So the content model would identify which content we needed, how it should be described, how the different parts of that content would relate to each other, and then those in turn would inform the kind of information architecture for the website as a whole. Because if you recall, it's not a single IIIF viewing experience, there's lots of other content around that IIIF. So you can see here a detail from one of our online whiteboards. Part of the problem with this project was it launched just before the pandemic hit, and we had planned a whole bunch of in-person activities, and then they all had to go remote. So you can see here a kind of whiteboarding session where we're working through the content model for the site, and you can see the big blue circles for the Codex, the volumes of the Codex, books, chapters, and so on, and how they all interrelate. From this, we kind of simplified this to a core hierarchical concept model centered on key resources. So the Codex comprises 3 volumes, which comprise 12 books, each of which each book comprises around 200 and 300 folios. Each folio has 1 or more images, and those images are tagged with multiple different concepts from the Goines vocabularies. And then each folio has 1 or more texts, which may have multiple transcriptions in 2 languages, and multiple translations, often in 3 or 4 languages. There's translations both from NAWAT to Spanish and Spanish to NAWAT, and English from both. The content model was very clearly informed by the Getty's concept of the 3 narratives, which Kim and Alicia talked about in the video we saw earlier. The idea that there's a Spanish narrative, there's a NAWAT narrative, and also the narrative that's found in the images or the illuminations that are found through the text. And it was really important to them that these 3 narratives would all be present in the user interface. In terms of the kind of user interface paradigm, we were thinking in terms of a generous interface, which is a fairly widely used term in this space now. It's coined by Mitchell Whitelaw, who's an Australian academic. But the idea is to kind of contrast a rich browsable interface where the kind of scale and complexity of the content is available all the time, and the user can explore it in a kind of serendipitous way, from a kind of ungenerous search paradigm where you have to ask it a question and you don't necessarily always know what's there. So it's the kind of contrast between the two. So it was very important that the Codex as a digital experience would present all the information in terms of browsable facets. And there's a list here from one of our whiteboarding sessions, through people, through places, through, concepts, themes, through a different structural hierarchy of the volumes of the book. And these would all in turn be available and present for the user to see. So having come up with a content model and a way of kind of thinking about the broad features of the site, we went into a visual design phase, and we worked with a design agency on this. So we wanted to take our understanding of who the users might be, what they might want, the prioritization of their needs, an understanding of what kind of data we might have, and then this content model and information architecture, and use that to kind of put together a visual design. So you can see here some bits of various mood boards that were created. These are all looking at the kind of color scheme and the typography of the site. These are all drawn from other Mesoamerican material, manuscripts from the same time period, jewelry, and other objects. So we can see here colors taken from a folio of another Mesoamerican manuscript, here from some pigments, here from some jewelry that was also from the same time period. And then the final color scheme that we came up with is here on this slide. So it was all very tied to the kind of context that we were working within. You can see here, and you saw something very similar to this in Kim and Alicia's presentation, but there's a video of the actual site. This is one of the design sketches from fairly early on in the project. So we have the three narratives, the Nahuatl on the right, Spanish in the middle, and the image on the left. And then we have the kind of image-centric view where we're looking at an individual illumination or image from within the text. You can see there's actually 3 on this page. And that's provided in a kind of different way of experiencing the same content. So you've got your 3 narrative view, but also a way of exploring the images in more detail. And again, here is a visual design, one of our mock-ups from the search experience. The eventual search experience ended up being slightly different. So in this view, you can see both the image search results, the searches within the illuminations, and in the text are presented in the same view. But we found from user testing and some of our work that it was clearer to separate the two. So the eventual site has 2 different search experiences, but you can toggle between the 2 of them. In terms of the technology, we knew we were going to use IIIF as a kind of core enabling technology for the site. And we had to think about how we could map between the content model of the Florentine Codex and the content model or the kind of the structure of a IIIF resource. And so you can see on the right here, we've got the kind of IIIF-centric view of collections, manifests, canvases that are grouped together in ranges, annotation pages, annotations on canvases and content and so on. And these map quite nicely to the Codex. That's not a coincidence, right? I mean, the IIIF model was designed to facilitate these use cases, but you can think of the Codex as a collection, and then each of the volumes of the Codex as a manifest, each of the books as a range or structure comprising multiple canvases, each canvas representing a folio, and then on that folio, multiple images potentially, and lots of texts and other annotations. One of the key enabling technologies in terms of the actual technical development of the site is a tool called Canvas Panel, which has been briefly mentioned before, and I think Tom Crane's giving a presentation on that another time. But you know, a canvas in IIIF is a very key structure. It's a kind of the key bearer of a lot of the content, the virtual space that you paint a lot of content onto, whether that's an image or textual annotation, a tag, and so on. So given that we knew that the Codex would have 3 manifests, around 1,000 canvases per manifest, each of these would contain 1 or more images, multiple texts, multiple annotations, and so on. Canvases are a kind of key feature of the whole structure of the site. So Canvas Panel is a reusable web component that renders a IIIF canvas and all the annotations on it. And Getty funded work on Canvas Panel as part of this project, and it's used extensively throughout the Florentine Codex. It's also open source, and it can be used to build web applications that can use IIIF without the need to reinvent the wheel or understand much about IIIF at all. So you can see here in the site, we've got the 3 narratives view again, and the panel on the left is a Canvas Panel instance that comprises this is a deep zoomable view of the entire folio. But we can see that on another page, this is also a Canvas Panel instance, but in this case, pre-zoomed to just a particular illumination with a thumbnail strip, so you can navigate directly around the images on an individual folio. This is still a fully interactive IIIF component, so you can zoom in, zoom out, pan around from any of these thumbnails. And finally, the site has its own kind of bare bones, deliberately minimal book viewer that pops out a view of the Codex. You can see here it being viewed as an opening, but you can also view it 1 page at a time. And this is also a kind of Canvas Panel built book viewer that was built for this site, so just to feature what they needed for this particular project. You can also see here in the search results, there are many images. This is a search for fire. And these are all, again, Canvas Panel instances that have been embedded on the page in this case, using static images to kind of make it run more efficiently. In terms of how we mapped all these data sources to IIIF, the text was supplied as Markdown. We had over 10,000 Markdown files. These were then combined with IIIF, and each canvas had multiple renderings as HTML that was generated from that Markdown. And the IIIF manifest for each of these volumes contains the full set of these transcripts and tags. The manifests are gigantic, just as JSON alone. And then this text was then indexed and used to provide the search and the text display on each side. So you can see here an example of a search. We're doing search highlighting, someone searched for the word pyramid. So in this case, it's searching the English translation of either Spanish or Nahuatl text. Here, you can see the user can select which of the text that they want to view. So if you want to only compare one particular transcript, you want to just compare the Nahuatl text with the English translation of the Spanish, because you're a Nahuatl scholar and you don't really read Spanish, you can do that. Similarly, for the images, we needed to associate all of the vocabulary, the Getty vocabulary items with individual annotations on the page. So we used a tool called Matic, which is a crowdsourcing platform that DetektIIIF developed, which was used to generate the initial bounding boxes and identification of a particular region of a page with a given artist or scribe. And that was done inside Matic. But then this information was combined with exports from the Getty's vocabulary and the tools that they use to create those vocabulary entries to then combine together bounding box information and IIIF-centered information from Matic with this vocabulary information, tags and terms that were taken from kind of linked data, and then bring those together as annotations on all the canvases that then drive this image-centered view. And someone has searched here for cloak. Now these tags are multilingual tags. So what they're searching for when they search for cloak is a particular identifier in those vocabularies. And they could also search for this using the Nahuatl word or the Spanish word, and they would still find the same content because it's a multilingual tagging. You can see here on an individual image table underneath, and I think Alicia showed this in her video, that all of the different tags are available in 4 languages. So classical Nahuatl, which is the language used in the right column of the Codex, in Spanish, in English, but also in modern Eastern Huasteca Nahuatl that was translated so that indigenous scholars and others who speak modern Nahuatl can access the same content in the same way. So yeah, the Codex uses the power and flexibility of IIIF and Canvas Panel to bring together a content model and a visual design that was informed by user research, rich scholarship in the form of transcripts, translations, chapter summaries, audio, image tags, terms, articles, and so on in a single, generous, easy-to-use interface. Thank you very much.
Okay, so we're going to get into the rest of our program. We have 4 more presentations. The first is using Booksnake to teach with IIIF-compliant materials, and to present that is Sean Fraga.
Thank you so much, and thank you all for being here. Let me get this all sort of arranged. Okay. I'm here to talk about Booksnake. Booksnake is a new scholarly app that we're building at the University of Southern California with support from the National Endowment for the Humanities. I trained as a historian. I'm usually the beneficiary of the work that people in this room do to make cultural heritage materials online and available to researchers. So thank you all. It's really a joy to be talking with you. And as all of you know very well, galleries, libraries, archives, and museums, institutions in the cultural heritage sector have spent the past 20 or 30 years digitizing their collections and putting them online. This is really why we're all here today. These are the world's cultural treasures, but they have been locked inside of flat screens, where you have to click and drag and zoom in and out in order to apprehend the meaning of a piece of content, and you can never tell how big something actually is. Booksnake is our answer to this problem. It's a way of letting you explore digitized materials at life size in the real world. So very simply, here's what Booksnake does. Booksnake automatically transforms existing IIIF-compliant digitized archival materials into life-size virtual objects for interaction in physical space. This is something that is easier to show and a lot more fun to show than to tell. So I'm going to switch over to Booksnake itself and subject myself to the perils of a live demonstration. Oops. Okay, so the laptop here is connected to my iPad, and if I open up Booksnake, you can see here items that I've added to my Booksnake library. But what I want to do with all of you is add something new. So I'm going to go to the Explore tab here and take us into a search field for the Library of Congress. Could I get the name of a major American city?
Austin.
The first thing I heard was Austin, Texas. Okay, so we're going to send that search out to the Library of Congress, and what we're going to get back is the full Library of Congress website. This is exactly what you see if you searched on your laptop or desktop, wrapped inside of Booksnake. And because it's the full website, I can do all of the things that I can do online, including sorting and filtering along the left side here. So I'm going to select Maps and look just at maps of Austin. And do any of these look good to you? Pick a card, any card. Number 2 here. Number 3. Okay, we've got a Sanborn fire insurance map. I love Sanborn maps. And here at the Library of Congress website, you have all of the rich metadata underneath it. I'm going to tap this Add to Booksnake button. And Booksnake is going to go out. It's using IIIF to download this item. I'm going to stay on the page here. Go back to the search results. And we'll take this very first result of Austin County as well, add that to Booksnake. And this time I'm going to go to my library view, and you can see that the Sanborn maps have already downloaded there, and that second map has downloaded as well. And so now when I open up either of these, I get the same information that I saw on the Library of Congress website, including all of the metadata available, or at least the metadata that Library of Congress has taken from its MARC records and put into its IIIF manifests. And at the heart of Booksnake is this blue View in Your Space button. And so when I tap that, it's going to open up a live camera view and insert that digital object into the camera view at life size. I'm juggling how to do this with the microphone here, so I'm going to go off mic for just a second. So first I get a preview, and now that I've anchored it, I can go up and say hello to all of you. Here you are. And if we come back, the item is here where I left it. And from here, I can treat it exactly as if the physical object is in front of me. I can step in close to get a sense of the details here. You'll notice it's drifting because it's a little dark up here at the front of the room. And because this is a Sanborn map, it's multiple pages. So if I swipe across the edge, it's going to open up. And I can continue to swipe to explore and move in close to focus on any of these details here. Okay, so back to the presentation. I want to start here by underlining how Booksnake is different from existing image viewers. First and most obviously is the place of interaction. Instead of a flat screen, Booksnake brings you into physical space. Second, where current image viewers are observer independent, they pull what Donna Haraway calls the God trick of seeing everything from nowhere, Booksnake is observer dependent. It depends on your relationship to the physical space around you. Third, current image viewers rely on indirect manipulation, click buttons and drag content in order to navigate an item. Booksnake instead relies on physical interaction, movement within the space, moving the device and moving your body. Current image viewers arbitrarily scale content to fit the user's screen. Booksnake instead displays items at their life-size dimensions. Current image viewers display images. This is the whole point. Booksnake instead displays objects. These are virtual objects that are built from digital images. And then finally, most important, image viewers are a vehicle for visual information. Booksnake, in contrast, creates the feeling of being in the presence of the object. And this is a surprisingly powerful feeling when you actually are handling the iPad itself. It's disorienting to look past the iPad and realize that there isn't an object there in front of you. So very briefly, here's how Booksnake does this, moving left to right. Booksnake first uses IIIF to access and download and manage images and metadata. Then, in the middle, Booksnake uses Apple's Reality Kit to automatically generate a custom life-size virtual object. And then finally uses Apple's AR Kit to display the object in physical space and to handle user interactions with the object. So what? What's the point of this? Is Booksnake useful for teaching? Over the past 2 years, we've used NIH funding to investigate this question. Does interacting with archival materials in augmented reality change student learning outcomes when compared to interacting with archival materials in a web-based viewer? And today I'm going to share some initial results from our largest and our most recent classroom study. My colleague at USC, Dr. Eric Heller, invited me to observe his use of Booksnake in his introductory course on Mesoamerican worlds and culture. This is a 100-level lecture course, about 94 students. In addition to attending weekly lectures, students also attended one of 4 weekly discussion sections. Each of those had about 23 students. And these discussion sections are where Eric deployed Booksnake. In each of these discussion sections, Eric split the class up into groups of 3 or 4 small groups, and then split the class in half. So that one half started by exploring some Mesoamerican codices in a traditional flat screen web viewer, and the other half started by exploring other codices using Booksnake. And then about halfway through, everybody switched so that everybody in the classroom got to experience the technologies. You can see some of the students using Booksnake here. They pinned one codex to the wall in order to explore it. And in both cases, the learning task was the same. This wasn't about the technology. Instead, Eric asked students to identify moments of Mesoamerican and Spanish colonial cultural exchange in these codices. And this required students to pay close attention to how the codices visually depicted knowledge about the world, things like plants and animals, the routes described for different journeys or voyages, how cities are depicted, things like that. And at the end of each class, students completed the Instructional Materials Motivation Survey, or IMMS. This is a standardized instrument that assesses student learning motivation with curricular materials across 4 metrics of attention, relevance, confidence, and satisfaction. And a grain of salt before I take you into the data on the next slide. What I'm about to show you is the raw data. I haven't yet done the statistical analysis to establish significance or impact for any of these 4 variables. Okay, so the IMMS uses a 5-point scale. 1 is low, 5 is high. Here's how students rated the web viewer. And here's how they rated Booksnake. So on the whole, they rated Booksnake as slightly better than the web viewer across all 4 of these measures. Notably, the first measure, attention, Booksnake held their attention slightly better. We also saw this anecdotally. Students wanted to keep using Booksnake. Eric had to be firm and direct in asking students to surrender the iPad to another group and switch over to using their laptops to look at the other codices. And then finally, the biggest raw difference here is in satisfaction. That students told us Booksnake was more satisfying to use for these learning activities. We also asked about qualitative feedback. And here are some representative responses from this instrument. First, you could get really close to the source. Students told us that Booksnake makes it feel like they are in the presence of a physical object. This is the whole thing that we're going for with this stuff. And for some, this presence and this proximity to the virtual object made it easier to focus on the details and the content in the object itself. Another student wrote, I liked being able to look closely and focus in on one image at a time. This is close reading. This is what we as humanists are always trying to impress the value of upon our students. So it was gratifying to see this unsolicited in the responses. And then finally, my favorite response, one student wrote that Booksnake gave them the feeling of actually seeing the real thing up close. This is a remarkable comment because of course they aren't seeing the real thing. And they aren't up close to it, they are instead up next to a virtual replica. If you spend a lot of time around archival materials, you might see Booksnake as a pale imitation of an actual visit to special collections. And you'd be right. But my goal isn't for Booksnake to replace a visit to special collections. It's instead to extend the power of special collections, to bring the embodied experience that right now you can only have in a particular place at a particular time, out beyond that physical space, beyond the physical space of the reading room, to people who have never had it before, like these students. And for situations where, like a 94% lecture course, it is logistically difficult to bring students into that feeling of actually seeing the real thing up close. Here's another example. Booksnake also makes it possible to bring that kind of experience to places where it wouldn't otherwise be possible to work with archival materials, like remote areas. I'm teaching an environmental history course out on Catalina Island right now at USC's campus there. This is one of my students last week using Booksnake to look at a historical map. It's not feasible for me as an instructor to bring rare, fragile archival materials 26 miles out across the Southern California Lake to Catalina Island. Nor is it feasible for me to bring my students back to main campus. So instead, Booksnake is a way of bringing the experience of embodied encounter and discovery to them in our classroom. So ultimately, Booksnake is a reproduction technology, and it's my argument that it is a better reproduction technology, one that captures and communicates more of an item's contextual information than current flat screen viewers. I want to close with some of the best practices I've discovered for teaching with Booksnake. First, choose an embodied activity. Booksnake is about for learning tasks that ask students to engage with an object's physical features. So, for example, Booksnake would be more useful for a lesson about how a given poem appeared in print, how it sat on the page, the fonts that were used, where the breaks are, than for a lesson that focuses in on the text of the poem itself. Second, show, don't tell. Show students how to use Booksnake. Booksnake is designed to be intuitive to use, and visually demonstrating how to use Booksnake will prepare all students to use it for themselves, just like I did for all of you at the start of this presentation. Plan for inclusion. Not every student will have an iPad or an iPhone. In cluster testing, I've brought iPads loaded with materials chosen by faculty members for students to use during the class. And by having students work in small groups with these iPads provided, it levels the playing field. It doesn't rely on students having a particular device. And then finally, this was the biggest surprise, and I think it's the most important one, make room for virtual materials. Most college classrooms aren't set up to work with large-scale archival materials. This lecture hall, for example, packs all of you in, but has very few flat surfaces. Space really matters. Students need room to stand up and to move around in the same way that they would in a reading room. I'm incredibly lucky to be building Booksnake with smart, creative people in a collaborative, multidisciplinary environment. I particularly want to recognize the developers, Christy, Henry, Michael, Zach, April, and Yuki, all of them USC students who regularly do the impossible. And I want to acknowledge our educator and technical partners under the NEH grant at USC, UC San Diego, the Huntington Library, and the Library of Congress. Booksnake is currently available as a free public beta for iPhone and iPad. You can scan the QR code over the booksnake.app to learn more about the project, to register for the public beta, and get the download link. It's one thing to see this demonstrated from the front of the room. It feels like special effects, and in a sense it is. It's real-time video special effects. It's something else to hold and control and experience those special effects for yourself. Looking ahead, Booksnake will launch this fall with access to Library of Congress collections, with more archives on the way. Booksnake's source code will be available on GitHub open source by the end of this summer. And again, we're building Booksnake to enable digital accessibility and to connect more people with primary sources in and out of the archive itself. The last thing I'll say, if you're interested in trialing Booksnake as part of your teaching, or if you're interested in talking more about bringing your institution's collections into Booksnake, I would love to talk more with you. Thank you so much, everybody. I look forward to the questions.
Thanks, Sean. Okay. Up next, we have Leander Siege.
Hello, my name is Leander Siege and I'm happy to give an update on the latest development of DetektIIIF, the IIIF browser extension. First of all, let me give a short introduction on what DetektIIIF actually is. DetektIIIF is a browser extension that tries to help the users to overcome the challenges that IIIF sometimes or often causes for them. The main feature of DetektIIIF is to detect IIIF resources in web pages and provide the user with convenient tools to work with them. From a technical perspective, DetektIIIF is a browser extension for Chrome and Firefox, and it analyzes the content of web pages and also sometimes the data traffic between web applications and servers in order to find IIIF resources. So the IIIF user does not have to manually search for IIIF resource links anymore. The user does not have to copy and paste cryptic links to IIIF manifests anymore, but instead the user is provided with convenient tools on each web page to work with those IIIF resources. And here are some basic features of DetektIIIF. If DetektIIIF finds IIIF resources on a web page, it shows a small number above its extension icon, and it provides the user with the functionality to collect links to IIIF resource in a basket. There are some other features as well, like for instance, some quality checks. DetektIIIF, for instance, checks for the absence of HTTPS or other quality features of IIIF, and DetektIIIF provides some convenient tools to work with those resources, for instance, downloading a full resolution image of a IIIF resource. This is how DetektIIIF looks like. If there are IIIF resources on a web page, DetektIIIF shows the number of them above its extension icon, and if the user clicks on this icon, a extension window opens which has tabs for each individual type of IIIF resources, and as I said before, it also provides this basket. The basket, of course, also has a list of links to IIIF resources. For instance, the link, of course, the links which have been collected by the users, and there are also a couple of buttons to work with this collection. For instance, to send this collection to a prepared external Mirador free instance. So, what is new in version 3? The most important new feature in DetektIIIF version 3 is that it comes with its very own entire Mirador 4 embedded. I want to thank the people behind Mirador who upgraded Mirador to the latest dependencies, especially React 18, and thus created Mirador 4 almost en passant. Now it is possible to not only collect IIIF resources in DetektIIIF and to send those collections to remote institutional IIIF applications. Now it is possible to open these collections in DetektIIIF's very own embedded Mirador 4 instance. Once you have such a Mirador 4 instance in your browser, the basket of the DetektIIIF extension and the resource collection inside this Mirador 4 instance is real-time synchronized. So each and every time you collect a new resource from a web page, it is immediately added to the Mirador 4 instance. In the extension window, there are two new buttons now to open exactly this local Mirador instance. So the user has a very easy way to find and open this Mirador 4. This is absolutely not surprising, this is how the Mirador 4 instance of DetektIIIF looks like. If you look at the address bar of the browser here, you can see that this Mirador 4 instance does not come from any remote server, but it runs directly in the extension space of this browser, and this is the list of resources that has been collected in DetektIIIF. DetektIIIF stores this collection of resources not in the local browser store anymore, but in the synced version of the browser's storage. That means that instances of your browser associated with your Google or Mozilla Firefox account gets updated the very same moment you work on a browser on another device. So, for instance, if you travel with your notebook and work with DetektIIIF and DetektIIIF's embedded Mirador 4, the browser on your local machine in your office or at home is updated at the very same moment. So if you return to your office or to your home, you do not have to send your data from your notebook to your device. It gets synchronized in real time, and all the work you've done on your mobile device also appears on your machine at home or in your office, or vice versa. The next steps, and I can't wait, it's very tempting, of course, to also create and store and persist annotations in the very same browser sync storage. I'm happy that Mirador 4 exists and that I could integrate it into DetektIIIF, but unfortunately the annotation plugins for Mirador are not ready yet, so they can't be used with Mirador 4. Once they will become available for Mirador 4, I will also integrate, or I plan to upgrade these annotations Once the annotation the next steps for DetektIIIF. Of course, it is very tempting, and it was one of my first ideas when thinking about embedding Mirador 4 into DetektIIIF was to provide the user with tools to create annotations and to store those annotations independently from any institutional resource. So it is the idea to, as soon as annotation plugins become available for Mirador 4, to bring these annotation plugins also into DetektIIIF and the embedded Mirador 4 in order to give the user the opportunities to work with IIIF resources in the embedded Mirador and to store those annotations completely independently only on personal resources in the browser or in the browser's sync storage. Another idea, of course, is to open up the single basket approach of DetektIIIF and to allow the user to collect IIIF resources on separate topics in separate baskets. And there are, of course, a couple of further ideas like persisting the workspace configurations of Mirador 3, for Mirador 4, and so on. DetektIIIF is open source, so if you would like to check out the source code or help developing and improving DetektIIIF, or to tell me about problems, about issues with it, about ideas how to extend and improve DetektIIIF, then please feel free to contact me and check out the source code, or if you have other ideas how to integrate DetektIIIF with other applications, then please let me know. Thank you very much for your attention. DetektIIIF is available in the Chrome Web Store right now, and it should become available in the Mozilla Firefox extension store as well. And here are a couple of other ways to get in contact with me. Just feel free to send me messages, and I'd be happy if you give DetektIIIF a try and tell me what you think about it. And I hope that it will help you and other users in the future to work with IIIF. Thanks and bye-bye.
The IIIF Manifest Editor, latest developments with John Baker and Paul Mollahan.
Hello everyone, I'm John Baker from the Manchester Architect Digital Arctic. I'm joined by my colleague Paul Mollahan as our Service Director. He's of course working on product owner for the Manifest Editor. I'm going to just give you some overview of some latest developments. So I'll give you a bit of background on where we have got to where we are now, and then Paul will give you an overview of work in progress and what could do next. Okay, so many of you will already be familiar with the Manifest Editor, your digital training or your own manifesting endeavors. We're new to it, basically like a standalone web-based editor. You create a manifest from scratch, or you can edit new, simple, or complex manifests. Importantly, you can also integrate into existing platforms and be configured for specific steps in your workflows. Such as checking and validating our pushing digitalization, OCR processing, or further kind of post-processing for external enrichment. So there's a strong focus on simplicity, but dealing with adoption. So the tool that take for people of both ways of converted to decline.
and those that maybe are just starting to learn it and maybe not that technology. So we've worked with a number of funders and collaborators during the sort of organic evolution of this product. So initially, a lot of the initial work was very experimental, looking at the kinds of narrative forms like storytelling, slideshows, that kind of thing, online exhibitions. So we worked with the V&A and Delft. So they were quite desperate requirements, quite varied, as we were sort of finding our feet, what was required. And then when we got onto the second phase, working with, again with Delft, and also Water Collection for PAN, the UK programme, and they have a National Shipyard Foundation project which we worked on, which is trying to encourage people to adopt shipyards as part of that foundation. So the focus of this version was really to consolidate the functionality of all those experiments into something that was more easily maintainable and extensible. The simplicity is the key sort of guiding principle for both technical and UX design elements. Okay, so we're also looking to promote the doctorate design for smaller corporate heritage institutions through the TANK IIIF sandbox. So the idea here is that we bring together lots of existing background information, new material around IIIF, together with a IIIF hosting service, which is now one called IIIF Cloud Services, and the Manifest Editor, so that people who just want to learn IIIF, maybe in smaller corporate institutions that don't have all the infrastructure and support, can just get started themselves, upload a few images, create a very simple manifest, and then use the manifest to really explore presentations, really what you can actually do with the manifest beyond that. And this is something we'd like to extend to other smaller institutions and communities, so we're open to suggestions if anyone has any other ideas of the ones that we could explore that. One idea that we've used a couple of times with the liberal arts colleges here in the US could be a good option. So we're very pleased to say that we have further collaborations and partners working with us within this form of Canadian Research Knowledge Network, or CRPN. So they've got a number of interesting use cases which are basically to help support their digitalisation workflow. So creating and managing IIIF collections is very important to them because they, in the way that they actually manage their digitalised materials. Also merging manifests, section reordering and moving of classes within a manifest, creating multiple new manifests from one very large one, and also bulk management of manifests, which is like things like pagination or updating particular fields for every canvas within a manifest. So I'm interested to understand more about whether these use cases are other people that are here today, and whether anyone else would like to collaborate on taking this manifest further forward. So also, Canada are very kindly offered some funding to make some more generic improvements to the product, which are doing before we build these new features, and also ensure that we cover the full presentation through baseline of everyone. So as you'll see in a moment, the UX improvements are coming along very nicely, and Paul will also thank you for that. Thank you for the work in progress. So yeah, thank you to CRPN and hello, bringing over not seeing you in this conference. Thank you.
Thanks, John. Okay, so I'm going to take you through the work in progress that John has mentioned. Obviously, as John has described, the Manifest Editor has had a number of iterations to date, and I guess in that time there's been lots of user feedback, lots of issues raised, and ideas to kind of enhance and improve it. But I think as the Manifest Editor has grown organically, one of the things we really want to do was ensure that the user experience, which is kind of stop-started, that we kind of address that. So as part of the work to date, we've done some user interviews with some of you in the room today, and Brittany completed some user testing with the team at CRKN, and the outputs of that, plus further UX in-depth review was completed. And that allowed us to kind of identify a series of themes and prioritize areas to allow us to help improve the product itself. And John mentioned, I think, in terms of what we're looking at for this phase of project, we're really focusing primarily on people who wish to learn IIIF or are possibly already IIIF literate. But we do anticipate that the outcomes of this design foundation will hopefully address all user needs and really help to improve the usability of the tool itself. In terms of the areas of interaction, there's two primary areas. So really, the first one is the current kind of starting page. So where people come to as first-time users, potentially start off with the Manifest Editor, but then also for those people who are returning and working on Manifest and need to quickly focus on task at hand. And then secondly, this is the kind of the main Manifest editing view itself, essentially where people do all of the work of editing and interacting and validating Manifest and their contents. Now, the summary themes here kind of indicate the main areas or issues that come out of user testing and user interviews. And I'll just mention briefly one of them, which is the kind of Canvas versus Manifest interaction. This is something that has come up a number of times, and it's really what we're really looking at is trying to make that clearer for people so they can kind of understand what they're working on and orientate those users as they move between those two separate views. In terms of some of the outputs of the foundation work itself, we've built a style guide which is being iterated and updated at the moment, and a separate component library where all of the component interactions are being documented with intent explicit, just to kind of help guide development and testing. I mentioned that obviously earlier one of the key challenges with the user feedback or this question of Manifest versus Canvas. I think one of the things that we really found was that the team felt it was really important to look at the kind of hierarchy of interaction and how that worked within the tool itself, and to see if that could help kind of address some of those problems. And I guess, as illustrated here, I'm not expecting you to read all of that, but as illustrated here, the idea is that we really want to make sure that the control of the tool is clear and consistent, so it's kind of left to right. So when you start to interact with a canvas, for example, everything that you see follows from that. So I'll show you that a little bit later. Briefly, this is just a visual of some of the changes that we've implemented. I'll just mention one element, which is just the new left-hand menu, and that is helping us to kind of distinguish between Manifest and Canvas, but it also allows us to add more editorial tools on the left-hand side as well. Briefly on the technology side, I think the main focus as part of this foundation of work was to simplify the application even further and really just make the different elements, I think, leaner so that it's easy to focus on the things that they need to do as part of the overall application structure. I'll just mention that the shell, it uses the IIIF Commons Vault, which is a tool for managing state, while the Manifest Editor, similar to what Matt mentioned earlier, it uses Canvas panel as well. So we're trying to reuse a lot of existing components and build on the stability of those. Some other technical enhancements in this phase. So we're trying to plug the remaining gaps in IIIF presentation API, so the tool supports everything now. But it also supports the ability to kind of turn things on and off as you need them, depending on your institutional needs. And I'll just mention finally, we will be publishing a series of NPM modules that will be available for the community to allow people to download and install this themselves. Okay, very briefly as well, in terms of documentation, the aim is to produce some additional documentation to help support users with the tool. We hope to help increase adoption. So there is additional signposting and help text within the tool, but we've also been busy collating a wide range of example resources, which we're going to make available alongside the tool, just to make it easy to kind of explore and see how those can be used as inspiration. Okay, I'm going to demo, which I said, yeah, hopefully this video should work. Okay, sorry. Okay, so I've just really quickly opened the manifest from the National Library of Scotland, and here on the left-hand side, we've got the high-level descriptive metadata, the manifest, plus the center panel now gives you an overview of the entire contents of the manifest, and on the right-hand side, we've got the metadata properties for the manifest itself. So when I click on the canvas section, again, you can see, so the center is now that particular canvas, and we've got this grid view, which is a thumbnail view, sorry, to allow you to kind of navigate visually through it. There are also tools to allow you to edit, so maybe move some presets to start to finish, for example, or to describe, which I've just done there. And then finally, this add new canvas option allows you to create whatever type of canvas you need, blank or something like HTML. There is a preview link, but I think you can see it there. And within this, we've just opened the manifest that I've just changed using UV, and you can see that change that I've made is available. You can see that. Second manifest, so this is an example of the manifest that we've been working with Jules and his team at Delft. So this is a more complex manifest example for an exhibition that they're building at the moment. So this has got a mix of canvas types. So this one is just an image, but there is HTML, and in this one we've got multiple images. So on the right-hand side, I'm interacting with the media on that canvas. I think just as an example here, you can see just moving and repositioning that particular image on the canvas itself. And then previewing this in the Delft viewer, which is a custom viewer has built as part of this exhibition. Yeah, you can see the adjustment, but obviously it's a very engaging set of content. And then the final example, so this is an example from the Victoria and Albert Museum. Some of you may be familiar with this because we've used it before, but as inspiration for the original manifest. So in this instance, this poster has got, so there's a series of annotations created to support a tour and allow users to navigate through the poster itself and see the annotations with some HTML and images. And here in this example, I'm just correcting that annotation, the bounding box, or attempting to do it. It's a little bit tricky on the size of the screen I was working on, I think, when I was doing that. And then I guess one point here is the patterns that we've used for components. So again, I'm dragging these annotations, but you'll notice the same pattern that we're using for components throughout the Manifest Editor tool. Here we've got a series of additional options for drawing bounding boxes. So there are some preset options, but there's also freeform now as well. So you can draw all types of bounding boxes that you need. And I think in this example, I'm using the Anona viewer and then just toggling on the annotations so you can see those, and you can see the slightly adjusted example on the right-hand side from the Garden Lounge. So hopefully that gives you a bit of an idea of the developments that have happened to date. We're almost ready to finish testing that, and hopefully we'll release that version very shortly. In terms of what's next, as John mentioned, there's a series of enhancements coming. So one second. Okay, I was just going to mention very briefly some roadmap items. I'll just really focus on some more editorial examples. So these are specific to manifest editorial editions. And what we're really aiming to ensure, I think, with all of this is that the functionality that we're developing works for a range of different but similar use cases. And obviously, this has been informed through discussions with CRKN. So, I've got a very brief video just to show some examples of this. So here we're showing in the left-hand menu, we've got what we're calling the grid editor view, and this is kind of an extended workbench to allow people to kind of reorganize the contents of the manifest, for example, so dragging and dropping, for example, or deleting, or importing directly from another manifest in a number of different ways. And really, it's just the idea of kind of providing that visual interaction between different sets of content. We're also adding a range editor, and again, kind of separating out that functionality so it's a little bit clearer and easier to use. So here we're adding a series of simple table of contents with the individual items themselves. And once we've kind of added that, we've also provided the means in which you can visually see how that's kind of laid out. So hopefully help people when they're working on those. And I think that is everything. Thank you very much.
Thanks, both. And now our final presentation for today, 10 ways AI will affect archives. Sara Brumfield and Ben from
Yeah. Okay, while Gwen's getting us set up, everybody want to take a really deep breath? We are almost done. Okay, so over the last 18 months, we've been running experiments, making changes to from the page, and observing what's happening elsewhere in our ecosystem. And from that work, we have 10 specific examples of how AI is going to change archives and digital libraries.
So the first way is improving accessibility. So let's start with this example. So this is a letter that's hosted at the Folger Shakespeare Library's early modern manuscripts online platform. It's been transcribed diplomatically, so the original spellings and punctuations, abbreviations, they've all been retained. So that's the scholarly standard, but it's not very accessible to a modern reader. So staff at the Folger also created a regularized version of the document, which retains most of the original wording, but it expands abbreviations, brings the spelling up to the modern standard. That works a lot better for people using screen readers, which struggle with those abbreviations, and it works a lot better for full text search. The problem is that's a really labor-intensive process. Staff at the Folger have been trying to automate it for a while. So we did a test trying to pass that diplomatic transcription to ChatGPT and compare its regularization to the one that the staff at the Folger produced. And I've got to say, it is pretty good. If you look at the third line from the bottom, it even got your lordships right.
Which is in the original LPS.
Yeah, it's LPS.
LPS.
Yeah, right. The Folger version is a little closer to the original wording, but in my estimation, the ChatGPT version would work a lot better for a screen reader. So imagine that as an automated process on your primary sources.
So our second idea is to use large language models to extract entities. So we did some experiments where we asked ChatGPT to identify the people named in a historical diary entry. This is from a project that we run on From the Page. It's a Virginia tobacco farm diary. So it did a really good job identifying all the people mentioned in the entry. It even gave us context, actually. It even gave us context. You know, who these people were and what they were doing, which wasn't exactly what I asked for. So I asked it to go back and simplify it just down to the names of the people. So this also works surprisingly well for place names. I don't know how useful it is because the places that are referenced in this particular entry are things like the schoolhouse or the mill, but it did find them.
So that's great if you're working with a text which you know nothing about. But what about connecting entities and text to an authority file or a list of people on finding aid? We did an experiment with the same farm diary. Fortunately, volunteers had already tagged all of the entities in it, so we had a ground truth that we could use to compare the AI result with the human indexing. First thing we did was extract the manually created entity names from the diary. So I pulled out the 100 most commonly used entities to match against. I also thought it would be interesting to provide the large language model with a bit more context. So I added information about whether the entities were people, whether they were enslaved or free, or perhaps were places or companies. So this is the prompt I used. After the word entities, I'll provide you a list of entities and a category which entity is. After the word text, I'll provide the text of the page. Map them up. How to do? Again, pretty well. It extracted these people, and it was able to match almost all of the entities in the page of text correctly. I was especially pleased with the fuzzy matching you see in 6, 8, 11, and 13, where it suggested possible matches in the case of ambiguity.
So we also think describing items has a lot of potential. Matt Miller at the Library of Congress did a series of experiments with the Susan B. Anthony collection, letters that Susan B. Anthony wrote. And one of the things he asked the GPT APIs to do was to summarize each letter in the collection. And that's what you see on the screen here, a 1-sentence summary of each letter. But do a couple of variations. While that first screenshot shows a 1-sentence summary, this one shows a 4-sentence summary. And there's a slider on the left that lets you change how many sentences are in the summary.
So let's talk about improving discovery. This has never really been much of a focus for us at Page, but over the last couple of years, some volunteers have struggled to find projects that interest them. As you can see, an alphabetical list is not that great. We ran into the problem of needing to provide discovery on our crowdsourcing platform so people could find the things that they were into. But we had 1,000 collections and their descriptions, which is pretty rough. So we tried using ChatGPT to automate the process and compare its results with the results that a trained archivist had done. How did it do? Well, again, it did pretty well. There is a lot of overlap between the human results and the AI results. In this case, it tagged a collection with China, which the archivist missed, but it missed travel, which the archivist had provided, both of which I think would be pretty valuable and more valuable than, say, university, for example.
And we did have human review before we actually rolled this out.
Yes, we did.
So this is back to the Susan B. Anthony papers. In that interface, you can highlight a term. Here, I've highlighted the word Catholic, and you can search similar text. Now, this is not a keyword search. It's what's called semantic search. It's more of a conceptual similarity search for things that are close to each other in this great big matrix that is a large language model. So here I selected Catholic, and what's returned are letters that have concepts that are close to Catholic. The first 3 results are actually about a fellow suffragist by the name of Sister Mary and the Unitarian Church. It's not until you get to the 4th and 5th letter that you actually get to kind of true Catholic references. So maybe it's not great in this case, but when you stop and you think about looking for things that are similar to other things, this list might be exactly what you're looking for.
Another interesting thing that we might be able to do is locate particular passages within documents based on their contents. If we go back to the farm diary, one of the reasons that we're transcribing this is that we're researching the enslaved people in the diary, and you want to know whether a page mentions someone that's enslaved. Well, with the transcription, Sara can ask, are enslaved people mentioned in the entries, and it gives a response. So we think about at least the state archives that we work with that have massive collections of legal documents that are dry as guts. They are wills, they are inventories, they are court suitcases. They are trying to serve descendant communities by finding the mentions of people within those documents. This is the kind of thing I think could actually help.
So what if you could interact with an archival collection in conversational language? This is another experiment that we've done with an archival project, the same one you've been seeing all along. And we ask a question and the bot returns the relevant bits of the collection and answers in plain language. So here's an example. So during my White Graves semantic search bot, ask a question. We asked, when did the children go to school? And what we actually do under the covers, I'm gonna do next slide for me. is very similar to what we showed with the Susan B. Anthony projects. But instead of looking for one concept that's similar, we're taking the question and we're looking for similar entries in the diary. And then we're taking the top matching entries and the question, and we're feeding it all into this prompt and passing that to ChatGPT, and then asking it to give us a plain language answer. So it's got a couple of steps. This is what's called retrieval augmented generation, RAG. So now I know a fancy AI term, which all that really means is go do some search, pull some stuff back, and then package it all together and use that to ask a large language model to generate text. What we think is pretty cool here, if you go back, is we actually show the matching entry. So I think there's a lot of opportunities for attribution and references back to your collection material.
Okay, tomorrow, I think we're going to hear about fully automated document transcription using handwritten text recognition technology, which is really exciting. We think that AI can also help when humans are at the center of document transcription. To that end, we've added a new AI assist feature to From the Page that lets users turn on a text overlay showing the HTR text on top of the image viewer. So that pans and zooms, so people can see what the AI thought a word said if they're having trouble trying to read it. But some users prefer using HTR text as a first draft. So for them, we've added a new AI text feature which populates the transcription editor with a text that is derived from HTR, but with emoji placeholders for words which a large language model thought needed correcting.
One of the other things we are super excited about using AI for is transcribing audio visual material. So we do a Mellon-funded project with Professor Tanya Clement at UT Austin called AV Annotate. She's here somewhere. And through that, we've learned just how much AV material is locked away in archives, right? There's permissions issues with publishing it. There are preservation issues. A lot of it is on plastic and it's degrading. It's about to get worse. Anything that we can do to make AV material more accessible changes that equation on whether we even preserve it and whether people use it. And if you want people to be able to find things. When you have a 3-hour-long recording and you want to find 15 minutes where they mention or interview a particular someone, that's really time-consuming and hard. So this is going to be a game-changing approach. So my next two slides I borrowed from our friend Will Hicks at the University of North Texas. And Will ran these experiments using Whisper AI, which is also by OpenAI. It's available to download and use on your own computers. The computer power requirement is pretty hefty. Will actually diverted some new large GPU gaming units for these experiments. Let's go ahead and play this.
That's kind of like Louis Armstrong, right on the back of that. It's a good start in Chicago.
So, go there. But so this first one features jazz musician Louis Armstrong. He's got a really beautiful but difficult to transcribe voice. It took Will's student days to transcribe this recording, which is what you saw on the very top. And it still has errors. The middle is another automatic speech recognition program for comparison. At the bottom is a Whisper's unedited output. The error rate for the human and Whisper was about equal. Whisper, however, finished this in a couple of minutes and it took the student weeks. Kind of the next example that Will brought to the table is one he kind of used to drive home some cost savings of this. So this is a Spanish language interview that UNT paid a vendor to transcribe. It's 51 minutes long. It cost $222 and they had the file back after 9 days. They couldn't actually justify the translation cost, which would have been between $500 and $1,200, depending on accuracy. So let's see how that compares to Whisper. So if you look, there's a transcription in the middle and translation on the bottom.
Ok, para comenzar la entrevista queremos primero conocer sobre sus orígenes. ¿Nos puede decir dónde nació y cuándo?
Mira, yo nací un 17 de mayo de 1943.
So Will couldn't really evaluate the translation, but it was readable and done on the same day. And for the transcript, he actually ran a diff against the text, and Whisper is like 90% the same as the human edit. And most of those differences were formatting of names,
numbers rather, contractions, punctuation, spelling differences in names. So substantially better than nothing. And from Will's perspective, it's high enough quality. So when we started from the page, we expected folks to have digitized material already in a DAMS with some metadata, and then to import that into from the page for crowdsourcing. What we found is that isn't always true. Folks are digitizing material because they want the engagement that comes from crowdsourcing projects. And then they're ingesting it into their systems with the metadata that's provided by crowdsourcing. Now, none of that has to do with AI, but if you think about all the ideas that we've presented today, you've got to start with digitization. And then we think you'll transcribe either with humans or with machines, or ideally a combination of both. And you'll take those inputs to automated processes that will help you describe those documents. And only after you've generated all that data, and it's going to be a lot of derivative data that our current systems are not good at managing, searching, and displaying, then you'll ingest it into your downstream access and preservation systems.
So what does that mean for IIIF? We're going to have more and more derivatives, whether they are textual summaries, AV captions, HTR data. And as AI data looks more and more as if it is authoritative data produced by library staff, we're going to have a greater need to track the provenance of those derivatives. So I think that we already have most, and perhaps all, of the tools to represent these in the web annotation data model. So I don't think that we're going to need to change the IIIF spec. However, I hope that we'll start to see more people in the IIIF community talking about the best ways to track these derivatives with new patterns and new recipes.
So we're excited about all this. It's super fun to experiment, and it's really interesting to think what's going to start appearing and what's feasible and what we can bring humans in to review some of these outputs. We hope you are too. So we have a newsletter that you're welcome to sign up for, where we send out our experiments and our thoughts. We'll be here for the next 2 days. We love to talk about this stuff, or you can send us email. So thank you.